Hey guys, in this section we're actually doing a lot of the stuff we did in 2.1, but we're writing the equations for the asymptotes. So domain's the same, interval notation's the same. We kind of looked at asymptotes last time, but now we're going to actually identify them. So the vertical asymptote, we actually found this. When you find domain, you find the asymptotes. So we set the denominator equal to 0, and we make sure there's not the same factors on the denominator and numerator. Horizontal asymptotes, this is kind of scary, but it's saying if we have two functions, a rational function, p of x and q of x, we're looking at the degree. So that the degree is the exponent, the highest exponent. That's what a degree is. So we're comparing the highest exponent of the numerator and of the denominator. Okay, so we would say p is the numerator and q is the denominator. And then we have three scenarios. If p, the numerator degree, is less than the denominator, there's a horizontal asymptote at y equals 0. If they're equal to each other, the horizontal asymptote is a and b. These are the coefficients. If p is greater than q, so a higher degree on the numerator, then there's just no asymptote at all horizontally. Okay, so we'll look at some examples of those as we go through. But these rules you're going to want to know. Okay, so here we have a rational function. Let's start with the domain and the asymptotes. So I'm going to take this, the denominator, and we're going to set it equal to 0 and then solve. Okay guys, this is a quadratic equation because the x squared, it's got 3 terms, so we're going to factor. So for factoring, we take the last term times this, which is just a 1. So it's just negative 28 and negative 3. So two numbers that multiply to negative 28 and add to negative 3. Maybe you see them already on the graph. Negative 7 times positive 4. So our factored form would be x minus 7 times x plus 4. And we like factored form because now it's really simple to solve. We take each factor, we set it equal to 0, and then we solve. So x equals 7 and x equals negative 4. That's these. X equals negative 4, x equals 7. These are our vertical asymptotes. Okay, so when we look at domain, that tells us that x cannot equal 7 and x cannot equal negative 4 because they're asymptotes. We can't have a 0 in the denominator. So for domain, we want all these lines. We have one line, then an asymptote, a second line, then an asymptote, and a third line. So that tells us there's going to be 3 intervals. So when you do domain, I want you to just go left to right. Out here, our x value is all the way out to negative infinity. That's an 8. Oops. How many times have you guys done that? Comma. And we go till x equals negative 4. It's not included, so we're going to put a parenthesis. And then union to combine our next interval. So now this one, we're going to pick up at negative 4, even though it's not included. We're just super, super, super close to negative 4. And we're going to keep going until x equals 7. Again, super close to 7, but it's not included. And then our next interval, guess where it picks up? 7, not included, and it goes forever and ever out to positive infinity. So these are just our breaks where we have our asymptote. Okay, so this is the domain. The last thing you're going to have to know is the horizontal asymptote. So we're going to look at our variables. See up here, 10. There's no variable, so the degree of our numerator is 0. There's no variable. And the highest degree on our denominator is this exponent. The biggest exponent is 2. And we call these numbers P and Q. So for this example, P is less than Q. So there's a horizontal asymptote at y equals 0. And you can see it when you look at the graph. It's along the axis. We never actually touch y equals 0. It's an asymptote. But that doesn't affect our domain because domain is only x values. So y equals 0 is your horizontal asymptote.